Hi, and welcome to this video on Concept 14, Graphing Single Variable Inequalities. Please make sure that you are taking notes in the packet, pause and rewind as needed, and write down any questions you may have. So this starts with some vocabulary, a throwback to these symbols that you should have learned before. We want to make sure that you all know what they are called. Please take a minute and think about what you know about these symbols. So these symbols are all things that we call inequalities. Instead of having an equal sign in an equation, we are now going to see inequality signs in these inequalities. The names of these inequalities are things you probably have learned before, but please be sure that you have is in front of them, because the word is tells us that it's the inequality symbol. For example, if we said 5 less than 4, we'd have to switch the order, and we'd have 4 minus 5. That would be a subtraction if we hear less than. However, is less than means that we're going to use the inequality, as in 4 is less than 5. So it's important that you have the word is in front of each of these inequalities. One way to remember that this first symbol is less than is to see that the symbol itself kind of looks like an L. You can write the word less using that symbol. For the next inequality, this one says is greater than. It does not look like an L. That's one way to remember greater. You may have also heard is more than, is bigger than. We'll often call it is greater than. All of those apply. The next symbol has this line underneath it, but otherwise looks pretty similar to is greater than, and that's because it is. It says is greater than, and this line underneath means or equal to. That means it could be one or the other, and it would still be true. Think about the example. If I told you I would give you cookies or ice cream, and I only give you cookies, I didn't lie, because I said I would give you cookies or ice cream. That means that it has to be just one to be true. If I had said I'd give you cookies and ice cream and I only give you cookies, that would be a lie. But this word or tells us just one has to be true in order for it to be true. Finally, the last symbol that we have is called is less than or equal to. And again, that or equal to comes from that line underneath. Take a moment to look at the statements below in the practice and determine if it is true or false. You're going to select the correct response. So for example, in number 1, I would read this as 9, and I look at the symbol. It matches this one here. So I say 9 is greater than 2. And I ask myself, okay, is 9 greater than 2? Maybe I want to picture where they are on a number line. I know somewhere down here. Okay, 9 is further down than 2, so yes, 9 is greater than 2. That is true. Pause and press play when you're ready to check the answers for B, C, D, E, F, G, H. So B says 8 is less than 2. 8 is less than 2. That is false. C gets into some negatives, so we have to think about what they look like on the number line. But it says negative 5 is greater than or equal to negative 1. Since negative 5 is further left on the number line than negative 1, we actually know that negative 5 is less than negative 1. So this statement is false. D says 10 is greater than or equal to 1. And that is true because it is greater than 1. It doesn't have to also be equal, just 1 is okay. E is less than or equal to 3. And that is true. Letter F says negative 4 is greater than 0. Again, thinking about where negative 4 is on the number line, I know that that is false since it's to the left of 0. Also, it's better to have $0 in a way than to be short negative 4, if you want to put it in the context of money. G says negative 5 is greater than negative 5. That is absolutely false, since negative 5 and negative 5 are actually equal. Right? This just said it was greater than, and a number can't be greater than itself. In H, it says 2 is less than or equal to 2. Now the important thing is that or equal to here, because this is indeed true. Because it had the or equal to in symbol, since 2 is equal to 2, this part is true. Certainly 2 is not less than 2, but it said or equal to, so this is true. Now, these inequality symbols have certain symbols that we associate with them. Greater than or equal to and less than or equal to show that the critical value is included. It's part of the solution. So we use a closed circle. So there's a circle with shading in it, which we call a closed circle, to indicate these included values. Now, the other inequalities, greater than, and is less than, are not included, so we use an open circle to indicate them when we represent these visually, like on a graph. And we always shade in the true direction. So we'll see a few different ways that we might shade in the true direction. A few different ways that we might visualize different inequalities, but we're always going to shade in the true direction. So for example, let's see number 1. It said to graph each inequality. If we read this, it says n is less than or equal to -5. The way we start is we put a circle on the critical number. In this case, -5 is the critical number because that's the one mentioned in the inequality. Then we have to ask ourselves, is this symbol indicating a closed circle or an open circle? Since we have less than or equal to, this symbol here, it means we're showing that the -5 is included, and so we close that circle. Next, we want to shade in the true direction. So n is a variable, which is unknown, but we want to ask ourselves, there's two directions we could shade. We could shade towards -4, or we could shade towards -6. If we replace n with those numbers, I'm going to rewrite this inequality, but instead use -4 is less than or equal to -5. We want to ask ourselves, is this statement, is this true? Is -4 less than or equal to -5? No, this is false. So this is not the true direction. But to check, let's try the other side, which we would, again, using the inequality, replace n with -6 is less than or equal to -5. And we're asking ourselves, is -6 less than or equal to -5? And this time the answer is yes. -6 is less than or equal to -5. So this is the direction that we are going to shade in. So we kind of bold the number line in that direction and we include an arrow on the end. Now this graph is now representing all of the places on the number line and all of the numbers that make the inequality true. Try number 2 on your own. This is part of your homework and we'll check it in class tomorrow. Alright, I wanted to try to zoom in a little bit, but I'm going to lose my notes if we do that, so we're going to leave it here and move on to number 3. I'm just going to erase a bit to get my workspace back. If you need those notes, feel free to rewind. Number 3 says x is less than 1. So to start, again, we're going to put a circle on our critical number. In this case, our critical number is 1 because that's the number in the inequality. And I go to find +1 on the number line, and I'm going to put a circle right on it. Now, this inequality says is less than, oops, wrong one, is less than, which is a not included symbol, which means that we use an open circle. So I'm going to leave my circle open. And this inequality says that x is less than 1. So I'm going to check a number to the left and a number to the right, 2 and 1. And I'm asking, are those numbers less than 1? I just realized I made a typo. The number to the left here, the integer to the left of 1 is 0, so this should have been 0. And we're asking ourselves, is 2 less than 1? No. 2 is definitely greater than 1, so this is not the true direction. And on the left, we have, is 0 less than 1? And this is true, so this is the true direction. You can check that this is the true direction by noticing that any of these numbers that we're shading over, let's take -4, for example. Is -4 less than 1? Yes. Any number that we choose on the left side, over here where we're shading, is going to make this inequality true. Math is a lot about looking for truth, so this is a really important idea. All of the numbers on the right side, for example, let's try 6. Is 6 less than 1? No, that is not true. All of the numbers on the right side of this inequality, in the number line here, would make this inequality not true, which is why we do not shade it, because we always shade in the true direction. Try number 4 on your own for homework and be ready to talk about it tomorrow in class. Alright, now we're going to talk about a real-world situation that happens at Chuck E. Cheese's. Maybe you've been there. It's a restaurant that has games and arcade stuff. And the menu at Chuck E. Cheese says that only children under 12 years old are allowed to order from the kids section. Okay, so only children under 12 years old are allowed to order from the kids section. Take a moment and list 3 different ages of children who are allowed to order from the kids section. Now list 3 different ages of children who are not allowed to order from the kids section. Finally, ask yourself, would a 12-year-old child be allowed to order from the kids section? Let's go over A, B, C, before we get to D. So there are a lot of different numbers you could have put for A. Children who are allowed to order from the kids section include kids who are 9, 10, 11, even if they're 11 and a half. As long as they are under 12 years old, they are allowed to order. You could have even put the age of a kid that's 2. These are all examples of ages of children who are allowed to order from the kids section. If you're not sure if your answer is correct, just bring it in tomorrow. You can ask. B says list 3 different ages of children who are not allowed to order from the kids section. So again, you have to be under 12 years old to order from the kids section. So someone who is 13, 14, 15, or all the way up. Someone who's 85, not allowed to order from the kids section. Any of these ages are examples of 3 different ages who would not be allowed to order from the kids section. Finally, and this is where we can have some good debate, would a 12-year-old child be allowed to order from the kids section? Now, some people sometimes think that yes, it's allowed, but what we're asking really is a 12-year-old under 12. Is 12 under 12? And in fact, no, 12 is not under 12 because 12 is 12. They are equal. So if their phrasing says under 12 years old, a 12-year-old would not be allowed to order from the kids section. So, if we are going to bring this back to what we've been talking about with inequalities, if A represents the age and years of a child, write an inequality that represents the ages of children who are allowed to order from the kids menu. So, the kids who are allowed to order are going to be kids who are under 12. So kids under 12. So 12 is going to be part of our inequality. And kids, the age and years of a child, they said is represented by A. And notice how I circled that value. A, under. If you think about under, we're thinking about things that are less. So we can use the inequality symbol is less than 12 to represent this situation. So if your age is less than 12, you are allowed to order from the kids menu. The key word in this situation was this word under, which is a translation for is less than in math. Now we're going to look at some more common inequality vocabulary that will help us make sense of real-world situations. This is in your notes, so please make sure you're filling in the table. For less than, the words under, certainly is less than, and fewer are pretty frequently seen common inequality vocabulary. For this symbol is greater than, you might see the phrase is over, exceeds, or more than as a situation where you would use this inequality symbol. The next two symbols are where it gets a little bit confusing because there are some backward sounding phrases. So this inequality is less than or equal to. But the words that tell us to use is less than or equal to are things like at most, maximum, and is no less than. And that sounds strange because it kind of sounds backwards from what you'd expect. On the other hand, this inequality, which is greater than or equal to, the phrases associated are words like at least, minimum, and is no less than. But think of it this way. If you need to be at least 16 to get your driver's permit, which I believe is true in New York, your age, let's say A is age, or let's just write the word age. Your age, if you need to be at least 16, must be greater than or equal to 16 in order to have your permit to drive in New York. In other words, you could also say that the minimum age for driving is 16. So, although these words can sound kind of confusing, it's important to keep in mind that there is this sort of switch and to be aware of that when you're solving problems. As you practice and solve more problems, this will make more sense. For example, the sign shown on the right is posted in front of a roller coaster at Six Flags Great Adventure. If H represents the height of a rider in inches, write a correct translation of the statement on this sign. Since this is a word problem, I'm going to use cubes to break it down. I'm circling any key numbers, and I see H as a variable. I'm underlining what they want us to do, write a translation. And I'm boxing some math action words. And this word at least is one of our new vocabulary words. If we flip back, we see the word at least means greater than or equal to. So right near at least, I'm going to put greater than or equal to. I've circled, I've boxed, I've underlined. Now and I've already actually even expanded on what we know. Now I'm going to put this together. So it said if H, I'm going to use the variable they gave. H represents the height of a rider. So the rider, just as a reminder to myself, H is the rider, must be at least, so greater than or equal to, 48 inches tall. So the rider must be greater than or equal to 48 inches in order to ride this ride. So a correct translation, always coming back to the question at the end, is H is greater than or equal to 48. For homework, try example 7 on your own, and we'll go over more examples tomorrow in class.